for what Galileo witnessed at Io is almost hard to imagine. Here is a place where hundreds of volcanoes are constantly erupting. These fireworks are due to Io's location. It is caught in a tug-of-war between Jupiter, Europa, and Ganymede. This back-and-forth gravitational pull distorts Io's shape, causing extreme heating in the moon's interior. Unable to contain itself, Io erupts with massive walls of lava and plumes shooting upwards into space.
We flew by Io, and we were expecting to fly by one volcanic plume from the volcano Chvasta that we knew about from a previous orbit. And we realized that the next flyby, the spacecraft was going to go through the edges of that plume. And what we didn't know was that before that next flyby, another volcano erupted, had a gigantic plume 500 kilometers high. And Galileo went right through it. So with Io, it was difficult to plan because you might plan to avoid one volcanic plume, but you didn't know you were going to fly through another one that had never been seen before.
Jupiter is surrounded by a constellation of 79 known moons. Of them all, Europa has been the most intriguing, dating back to the time when Voyager 1 took this image from 1.5 million miles away in 1979. Here appeared to be an unusually smooth and young surface, devoid of craters. Voyager 2 traveled closer and was able to make out a patchwork of crisscrossing linear structures. Galileo's images would be even more detailed and far more revealing.
Europa was, I think, anybody's superstar of the Galileo mission. Just the first couple of encounters with Europa with Galileo just kind of blew us away.
We found a region where it looked like pieces had broken off, like an iceberg, and drifts in a watery body and twists. People who study the Arctic recognize some of these floating patterns as clearly an area where the underneath was liquid.
Some of these rafts of ice were the size of cities. There were also indications of ice flows and the possibility that water had even flowed on the surface, all pointing to the existence of a subsurface ocean.
The magnetometer came through with the final piece of data that really nailed the ocean model. It was responding exactly as if you had a big shell of salty water.
Europa, about the size of our own moon, may hold more salty water than all of Earth's oceans combined. What had once been only speculation was now deemed worthy of serious consideration. Is Europa a place where life could, or does, exist? Ironically, the question was the beginning of Galileo's demise.
So we came up with the plan to basically ram it into Jupiter and sterilize it with the energy of the impact. It's something that I still second-guess myself about, was there another way? But the problem was, the vehicle was getting old. It was having failures, and we couldn't wait too long or we lose the opportunity. So we tried to figure out the perfect time to do it. And I guess we may have been a little conservative, but not by much.
With its fuel tank nearly empty, and knowing the spacecraft could possibly have on board microscopic life from Earth, Galileo was put on a collision course with Jupiter to eliminate any chance of colliding with Europa.
everyone. We'd like to welcome you to live NASA TV coverage of Galileo's grand finale. With me right now is Claudia Alexander. She is the 7th and final program manager of Galileo. We have a display right now that can actually explain what's taking place. Can you go to that right now and explain?
Yes, what we want to know, of course, is what's happening with the spacecraft. What's going on? You'll see that we've passed most of the major moons. We've passed Io, and we have passed the moons Phoebe, and we're actually going past the moon Amalthea at this moment. And believe it or not, folks, we are still collecting science data, and I am absolutely thrilled about that. We're still clicking along, and we're still doing it. So, you know, go Galileo, go.
It was very sad, trying to keep this spacecraft alive. Day after day after day, doing everything we can to keep it going and keep it going. And now we know that we have deliberately told it to take a dive into Jupiter and evaporate and never be seen again. But it's also very joyful because we know we can look back at an amazing mission.
Among Galileo's firsts was delivering a probe to measure Jupiter's atmosphere. Galileo was also the first to conduct long-term observations of the Jovian system, finding evidence of subsurface water on Europa, Ganymede, and Callisto, while adding new knowledge about Io, the most volcanically active place in the solar system. Galileo was also the first to fly by an asteroid, the first to discover a moon of an asteroid, and the first to see a comet hit a planet. Galileo's legacy, though, is as much about endurance as science. It is a story of a spacecraft and its team of engineers and scientists who faced adversities and overcame them through stubborn determination and extraordinary dedication.
We all still talk about Galileo with a smile on our face, and I think of it as, you know, it's like your first love, you know, and you know, I use your first love and your first child, and there's just sense of all of these great people.
When you think about the spacecraft itself, it might be tempting to think of the pieces of metal that are its constituent parts. But for me, the ideas that it has given us will remain, and follow-up ideas, what we want to do now that we know so much from the mission, will be its legacy. So for me, the mission is much more than steel and titanium.
So the final moments, there's a small group of us sitting in the main control room at JPL here and watching the radio signal as it finally vanishes. There were a couple of people who were crying. I remember Claudia Alexander, who is not with us anymore, was standing right there, and she just reached over and gave me a great big hug.
We are now less than a minute away from the end of mission. They are counting down here in space flight operations. The final moment in a great mission, Galileo is gone.